asked you guys that. So at the top, divided proportionally is going to be used to describe in a couple of the theorems that you have to apply today. So these theorems aren't used for proofs, they're really used as a statement that you're going to then apply to the problems that you guys see. So within the theorems that you see here, they'll describe something and say something is divided proportionally. So what that means is, let's say AB, you have segment ABC, okay, and we say that these segments are divided proportionally. What that means is that I can set up a proportion using the segment lengths. So for example, AB to BC. Notice that this is comparing, let's say that these two segments are simultaneously divided proportionally is what they say. Okay, so what I'm doing is I'm comparing the small to the medium of the top segment. And when I say it's divided proportionally, at the same time that that ratio is established, AB to BC, I'm going to go to the other segment and find the small and compare it to, so it's very similar to what we've been doing, and compare the small segment to the medium segment. So in this case, it's going to be x, y to yz. And if it's stated that it's divided proportionally, we can make those assumptions and assume that that's true. So if you guys notice, I compared small to medium, small to medium. Other things that we've already learned when we see nested triangles, for example, is the idea of part to whole. So for example, this proportion is also true, AB to AC, where AB is the short segment, and I'm comparing it to the long segment or the entire segment. So you have part to whole, AB to AC. What would you guys say the proportion would complete that proportion, would make that true? AB to BC, sorry, AB to AC is equal to what on the other segments? Okay, very good. And you just kind of follow the order in which you go. So small to large or small to the entire, it would be xy to xz. Okay, other things could be true as well. We compared the short to the medium, we compared the short to the long, and now let's go ahead and set up one for the medium. So BC to AC is also equal to blank to blank. What would BC to AC be equal to? So I'm comparing the medium to the entire segment. Okay, the ones coming through look good. You guys have the medium side length of the bottom would be YZ, and we're comparing it to the entire, which is XZ. Okay, so we're going to be given various things, scenarios in which we have to solve for a missing side or a missing segment. So down below here, when I'm taking a look at this next theorem, it describes, so I'll read it out loud to you guys first. So if a line is parallel, we've seen this before, if a line is parallel to one side of the triangle and intersects the two sides, then it divides those sides proportionally. So this side here that I'm highlighting, that I'm tracing, that side divides this segment so that it's proportional to this segment. Okay, so different and various proportions are established. So you can say DG to GE. Why don't I have you guys, without even saying it, type into the chat, what do you guys think DG, if this parallel line divides these two segments proportionally, I'm going to view these two segments like I did up here. Okay, so DG to GE is equal to, on the opposite side, what do you guys think that it's equal to? Yeah, super easy. It divides it proportional, so DH to HF. Very nice. DH to HF. Okay, so they go through and they establish all the proportions. And so now, like this, we would view this as the small. GE to DE would be true that it's equal to HF to DF. Can I have you guys go ahead and fill out the rest of the proportions with what you think, and then compare your answers as you go? Or actually, I'm sorry, I think I made a mistake there. Did I? Let's see, GE to DE is equal to HF. Yeah, I made a mistake. So that one should be HF to DF. Okay, give you guys a moment to figure out what do you think those proportions would be. Okay, so go ahead and check your work here. There's more than one answer for the last one. And that is comparing, that one is comparing the short to the short, and then the medium to the medium, or the long to the long. Okay, so basically it's really hard to go wrong with these problems because you have so many relationships that you guys can use. So there might be more than one way to solve the problem. You guys just have to decide what is the easiest methodology to use and then go from there. So let's say on example number 1, since I'm given the medium and the long for the left-hand side, that's probably going to be the best way to attack this problem, but there's more than one way to do the problem. So I'm going to start off by saying, since I'm given the medium and the long on the left of the triangle, I'm going to say 15 to x. Can you guys type into the chat, what do you think the rest of the proportion would be? 15 to x is equal to blank to blank. Okay, and you guys are getting much better at making sure you add when you want the whole. Very good, 20 to 28. Okay, 20 to 28. And I'm gonna look for things like, well, before I solve this proportion, if I didn't have a calculator, I'm gonna see if I can reduce 20 to 28, and I can reduce by 4s on each one of those. So 15 to x is equal to 5 over 7. And then from there, multiply. So at that point, you guys can cross multiply and say 5x is equal to 15 times 7. Again, when it's larger numbers and I notice that I probably can reduce, I go ahead and just leave that 15 times 7 and divide both sides by 5. At that point, you guys can reduce the 5 and the 3, or sorry, 5 and the 15 to get 3. And then 3 times 7 is 21. So x is 21. Okay, let's try a few more on this before I move on. So on the other side, or at the very bottom of this, there is I think mine got cut off. My notes were slightly different on my paper. So let me talk to you guys about this additional corollary, which is also something that is true. So before I move on, let me just make sure you guys are you all got that page, the bottom of page 8, x equals 21. Okay, and very similar to, and if I were to expand this beyond just triangles and looking at 3 or more sets of parallel lines, then I'm going to go ahead and draw for you guys that an image of what this is describing. Let's say you guys had, and I know there's not that much space here, either at the very top if you guys have space, or somewhere in between the problem. So I'll just draw it somewhere on top here. Go ahead, if you guys can draw for me 3 different three lines that are parallel to each other. And then what I'm also going to draw is 2 transversals. Okay, so this is saying if you have 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. So kind of imagine what we just did. If this had gone on further and this was a triangle, then basically these sides are divided proportionally. So I'm just going to add letters to represent the segments here. But let's call this A, this segment B, this segment C, and this segment D. And if you guys can look up, A is just to describe this length right here that I'm highlighting. So that this is A, this is B, this is C, and this is D. So rather than using just multiple letters to describe the segment. And so if it's divided proportionally, we can say that these proportions are true. We could say A to B is equal to C to D. And also notice that if you guys were to compare A to C, or actually instead of that second equal sign, I'll say and. Another thing that is true is that if I compare across the way A to C, I would just want to make sure I mention left to right, left to right. And if you take a look at A to C to B to D, look at both of those proportions and think back to when we first learned proportions. I talked to you guys about equivalent proportions. If I were to do the cross multiplication in my head here, are these equivalent proportions? Yes or no? Are they equivalent proportions? If you were to cross multiply, do you guys get the same products? Okay, so it's kind of nice because you don't really have to, you know, sometimes it's like, oh, you can go this way, but you can't go this way. These problems are nice because you guys can compare A to B, C to D, but you could also go the other way as well. And that's nice to know for the problems. Okay, so if we take a look at, let me see which problems I marked off for us to do. Let's try number, and again, we will just do one of several different types, but number 3, if you guys can take a look at number 3. So here we have the triangle problem. Okay, so a triangle problem where the mid or the line that is parallel to the third side cuts across and divides these sides proportionally. Okay, so if I were to do 10 to 6, I'll give you guys the first ratio. Can you guys write what would the second ratio be equal to? Okay, so I see 7.5 over x. Very good. So if you guys then multiply those together, you guys get 10x. 6 times 7 is 42. And then you guys, I don't know if you do any of you guys do this, but half of 6 is 3. So what's 7.5 times 6? So if 6 times 7 is 42, half of 6 is, and it's kind of breaking it apart, so it's distributive property, 3. So good. So 76, or sorry, 7 times 6 is 42. Half of 6 is 3. So 42 plus 3 is 45. So if you guys go on to solve it further, divide both sides by 10, and x is equal to 4.5. All right, so let's, and let me just have you guys type into the chat so far. How are you guys doing so that I know if I need to do another similar type of example? Is anyone struggling at all? And it's okay for you guys to say, can you show another example? Okay, so I'm getting just that we're all doing okay so far. So let me pick one where it was, it doesn't have the segments broken out quite like 3 does. Okay, so if I just use what I have in terms of the numbers that I have on the left-hand side, if I set up my proportion as 4 to 14, what would the right-hand side of that proportion have to be equal to? What's the right-hand side of that proportion have to be equal to? Good, Cody. Good, Christian. Okay, the ones all coming through now look good. Okay, it all looks good, you guys. So if I'm comparing 4 to 14, I'm going to want to pick the corresponding segment on the right. So 6 to x plus 6. Okay, can I have you guys go ahead and work through this? I would reduce the 4 and 14 to make the numbers a little bit smaller since they both reduce by 2 over 7, and then keep going with that. There was a question from someone about number 3. Why does the 10 go under? I think you're referring to me solving this problem, the 10 under, and that is just because I multiplied 6 times 7.5, cross-multiplied to get 45, and then 10 times x is 10x. If I'm solving for x, to undo multiplication, I divide both sides by 10. That's the 10 that's there. It's just me showing my work. Okay, you guys, good job. So x equals 15 in this problem. So make sure we distribute the 2 to the x and to the 6 to get 2x plus 2 equals 7 times 6, which is 42. And then 2x divided, if you divide both sides by 2, you guys get 15. Are we okay? And that's pretty much the types of examples that you guys would see with the triangles. If I can have you guys type in yes, we're okay to move on. And then if you type in no, let me know if you guys, no means that you would like to see another example with the triangles. Yes is it's okay to move on. Okay, and then if you did type in no, can you go ahead and specify if I lost you on the problem, if it was question 3 that you struggled with or question 5? And actually, I just see one person who mentioned no, so I might move on for the sake of time. And then I'll be sure to, when I have my breakout rooms, I'll pull that one person aside. So I can go over that extra example to save the rest of us time. Okay, so on, and I'll make a note of that. Okay, you guys, so on number 8, here we have that the 3 lines that are parallel, these lines divide the transversal so that they're proportional to each other. So what that means is you guys have 2 options in this case. You can say 5 to 4 is equal to blank, or you guys can go across the way, left to right, left to right. So can you guys type in the chat, what would the right-hand side be on this one? Okay, good. So if I did 5 over 4, I'm going to make sure I pick the top and then put it over the bottom as well. So x minus 5. And these problems, again, there's no one right way to do it. You guys could have also gone 5 to over x minus 5 equals 4 over 8. That's also another option. And then from there, you guys would just distribute. Can you guys solve the rest of the way and let me know what you guys get as an answer? Just an algebraic trick, if some of you guys didn't know this. One thing is that if I look on both sides and 4 is on the outside of something that has to be distributed, it's 4 times all of that. And then this is 5 times 8. If 4 can go into 8, what you guys can do rather than distributing is dividing both sides by 4. And then that's going to allow you guys to reduce the 4 into the 8 to get 2. I don't know if you guys all knew that, but then x minus 5 is equal to 5 times 2, which is 10. And therefore, x equals 15 is the correct answer. Very nice. Okay, and then the last thing we're going to go over is this last angle bisector theorem. Again, an application. So an angle, what does angle bisector mean? So this is the drawing that might help you guys to recall what an angle bisector is. What's an angle bisector? What does an angle bisector do? Okay, very good. It splits an angle in half, right? So the larger angle that's on top, if you have an angle bisector on the top and it splits, so this ray or segment is considered the bisector. The bisector itself is like the knife, like what is cutting the angle in half, and it's this segment here. It's cutting the top angle in half. So it's saying that it's going to divide the side opposite that angle. So this is the side opposite, meaning across from that angle, so that it's proportional. So that's going to mean that when you guys are setting up your proportion, you can either go 27 to 45 is equal to left to right is equal to left to right, or you guys can do top to bottom, top to bottom. So the two, but I would encourage, like, I think it's easier if we just do comparing these two sides that are not opposite of this angle. So 27 to 45 is equal to blank to blank. Okay, so let's come up with that expression. So let's say we did left to right, 27 to 45. And then we compare that to, it splits this third side so that it's proportional. So here's where the split occurs. So we want to compare this to this. Okay, so I have that the top would be on the same side as the 27, so x, and then it's going to be over. What would it be over? What's the expression for the right-hand side? Good, Christian. Very nice, you guys. So the difference is the total of both segments is 40. So if this is x, this would be 40 minus x. Oops. I think I typed something in accidentally. So 40 minus x. Reduce both 27 and 45 reduces by 9. So you guys get 3/5. Make that adjustment first so it's easier for you guys to work with those numbers. And then continue to solve the rest of the way for that. This just happens to be a popular number in the examples that we're doing. When I glanced up, I'm like, was that from the previous problem that we typed in that answer, or was it's just the same answer? So good job, you guys, typing it in. Go ahead and finish the problem. Okay, so the last thing I'm going to do is have you guys just do this last problem yourself. If you guys can set up number 11, you don't have to type in what you set up. Go ahead and just set it up yourself. You guys can look up if you get stuck, and then check your answer as you guys go, and type in your answer once you get it. If you can type in your answer and type out to me just a few words about how you're doing if you need extra help. If you do need extra help, what I'm going to do is conclude the lesson, but then pull out the individual students who might need a couple of extra examples and go over those with those students. So again, let me know how you're doing if you want me to go over extra examples with you once we're done. And again, if you guys can type in both the answer and how you're doing. If you guys are typing in the answer, I've seen only the answers are good that are coming through.